Hello, YouTube. So, sorry for the initial shaky cam. We will have you stable in just a second. I've had a fair bit of changes to the bench. I still mean to have an update video for the state of the bench to show what I have on it. But we have a lot of changes coming. I'm getting into RF, and I have some equipment to add to the bench, some stuff to remove and move around and make room. Got done earlier with a standard Captain Picard breakfast, coffee and croissant. Hey, Roxy. And today we have, let's get this oriented. My first 7.5 digit multimeter, a Keithley 2001, which unfortunately for me is very non-functional. It powers up. I know what issue I'm anticipating seeing, and unfortunately, in terms of documentation, I really had to power it up to get it on video for the first time to show what worked and what didn't, instead of just taking it apart, because the seller online sold it as working condition, and they didn't just power it up. They're a seller that sells a ton of this stuff. They show what tests they do, so I'm kind of disappointed there. But for YouTube, that means you get another source to see what can go wrong with these. Now, I have my suspicions. I'm not going to lead with those. I haven't opened it yet. I received it yesterday. I unpacked it. I left it just on my bench to reach thermal equilibrium after a day. Then I ran my tests. I made previous videos for documentation for the seller for that, because I'm gonna need some kind of resolution with them. But now that I've gotten all of that documentation showing this is exactly what works, this is exactly what doesn't work, and having thoroughly tested that, we're going to open it so you can see what's actually going on in there. So, for these, you have a couple screws in the back. That takes off this little plastic bracket, you can see there. Then that's usually covered by a cowl sticker. There's a screw there to take out. I haven't opened one of these before, so I don't know if you need to take these off or if it's just for the feet being there. We'll see. What kind of nice view can we give you of the whole process? Yeah, okay. Okay, I can confirm that the screws for the feet only hold the feet on, and you don't need to remove those. Alright, it might be these. Yeah. Actually, no, that shouldn't be it. I'm going to pause for a second and look this up. Okay, resuming. I took the time to look this up. So there are screws on the sides here, and there's a certain orientation you have to be in to be able to remove it. And if you look on the side while you're turning it, you can see that about here is where it will start to come off. Just do one side, then the other. You can see it has a kind of a plus minus one side, and you need a specific angle that it will come off on. Let's not bang my oscilloscope. Yeah, let's move that out of the way. So you can see you have to line the empty one with that small hole in the corner. And it's the same on both sides. And then you have the screws on either side here. And they just slide down a teeny bit, and they pop out. And always a good idea when you're tearing down something complicated, try to, like I've covered this in lab tips before, you can try to line things up somewhere, or you can get a piece of cardboard and stab the screws in on the piece of cardboard in a arrangement similar to where you take them out, or just, you know, label the cardboard as you stab screws into it where they came from. You could also go by labeling the order you took the screws in, so you know, all right, which one is next to take out. Okay, so now this outer housing and shielding should just slide off. We are on our anti-static mat, maintaining physical contact with that. What you heard was these this spring line snapping up after losing contact. That'll be kind of a ground bus. Just checking to discharge any of the power capacitors in there. So, let's have a look. I do see some material there that could be from cleaning. Let's see if we can. So that could be from cleaning, like if it was dirty and someone was using a cleaning agent and it got in just through the crack. I'm not thinking that's any problem. What we're going to be looking for, and we do see some stuff there. We're going to be looking for any signs that this has previously been opened or searched. Yeah, sorry for this. Alright, that'll have to do. And we're looking for any capacitor failure. So what I'm doing right now is looking on the surface, and I'm not sure how well it comes across. But I see a crystallization pattern. Yeah, I think that's coming across. Yeah. So that's material. Possibly, yeah, you can see it there. Possibly stuff that evaporated or outgassed off. I'm also going to be looking at everything I can see before taking off the shielding. And we need to be very careful after taking off the shielding. Let's go a little bit lower in light. Alright, so there's going to be a lot more to look at after we have the shielding off. I don't see immediate evidence of capacitor failure, but I can only see 2 capacitors before taking this off. So, and we do have splotching and such on here. I'll turn this over. And I am not seeing any evidence of capacitor failure here. At least none on the capacitors that are visible so far. So, okay, carefully. Maintaining contact with the ESD mat with my skin. Both arms in contact with ESD mat. And let us very gently take care not to force anything. Let's see. Okay. So this ferrite core needs to be pulled up. So we will do that. As you can see, it is in the way of removing that. So we will gently, because these plastics can get brittle as they age. And if you've watched other teardowns of these, like from Ian Scott Johnson and the Signal Path and Marco Reps, I know one of them showed that they had a breakage on these. So we will take the care we can. Slide this up. And the second little leg snaps into the retainer for the first. So then this is getting kind of tight for some of the leads. So it's not quite all the way off, but we'll see if that's enough. And then you can see just slide it under there. So it was kind of difficult to get that fully out. And it's in fact not fully out. You can see there. So we're actually going to put this back in just a little. Just so it's not left in a strain condition. That way if we bump against it, we don't want to snap the plastic. And we just slide it down a bit, not fully. And now it's no longer under strain. So now we can see all of the power capacitors. And I am not seeing capacitor failure. Not yet. Let's get some magnification. So one of the common ways for these to die is theoretically there's a bad batch of Nijicon caps around about the time that early 90s that they were making these. I'm going to pause the video while I just eyeball everything. Oh, wait. I don't need to. Never mind. yeah, let's just... Well, fortunately, this acted as a shield, so that's good. Jeez. So yeah, we have a failed component. It doesn't mean it's going to be the only one. Let's see if you can see that. So it's kind of grainy, but yeah, you can see that blown out IC right there. The magic smoke got let out. Now, there can be cascade failures with these models. So what we have to worry about is other components having failed. It requires a thorough and tedious eyeballing before even trying to do any further electrical diagnostics. But the Mark 1 eyeball is where you start out and you literally just look for, has anything obviously exploded, caught on fire, or let out the magic smoke? And we can see right there that component has. So let's, yeah. So yeah, that is either U or V310. And we'll look that up because thank you XDevs for your wonderful database of resources. We have schematics. We have rather comprehensive schematics available, if I remember correctly. So we have one dead component. I'm going to pause and I'm going to look this over and see if I can point anything else out for you. So yeah, resuming here. Let's zoom back out. So I've given it a pretty careful eyeball. And I'm like ESD paranoid with that shielding removed. So I've been careful to like religiously maintain contact with my mat. And if I have to pick it up to rotate it, then I have like both my arms on my mat while touching the outer shielding to give it dissipation to ground. So yeah, the eyeball visual inspection without any further teardown, because there is more stuff you can see, like, you know, the reverse side of the traces on the opposite side of the board after a full teardown, you can see that. But the common failure mode, the nightmare failure mode with these Keithleys, is these capacitors. Capacitors on your power. In theory, like, these are Nichicon Chemicon capacitors. That is a very reputable Japanese company, widely considered to have made the best capacitors in the world, and still do. The theory is that in the early 90s, Nichicon had a bad batch, and a lot of Keithleys, the 2001s, had capacitors that were prone to leakage, and a lot of these beautiful instruments have been destroyed beyond pragmatic repair, from the capacitors leaking corrosive electrolytics into the board, and it would eat its way inside the board along the copper trace underneath the solder mask. And at that point, depending on how far it goes, the damage is extensive. And what complicates that further is if you have a power on condition with all of that corrosion and damage, then a common secondary failure mode is a cascading multi-system failure, where the power system, because it's no longer being properly regulated, introduces overvoltage conditions and just fries a bunch of stuff and destroys this beautiful piece of history. it doesn't look like that's what happened here. Typically, if you have capacitor failure, all you have to do is eyeball it. You look just around the base of all the caps, and it's not like it's hard to see. You'll see evidence of like dried discoloration fluid. You'll see the solder mask and the PCB bloated, lifted up, maybe some bubbles, and that's the indicative presentation of cap failure and leaking caps and how it destroys this. But so far, all I've seen, and that does not mean it all, or it's all it is, because I don't know if this is a single failure or if this is like a failure brought on by something else failing. Like this could be a secondary failure to something else. Let's zoom in. Sorry. So it's kind of grainy because I'm zoomed in. But yeah. You can kind of make it out. Yeah, there. You can see that dot in the center of that chip. I mean, I'm sorry about the glare, but... yeah, that's where the magic smoke came out. Right there on... It's either Victor 310 or Uniform 310. And we will look that up and see what component it is. Hopefully it's not expensive to replace. But then we also need to find out, like, in order for that to get overvoltaged, most likely something else had to go wrong in order to deliver that overvoltage condition. So further diagnostics will be needed. Let's zoom back out. Yeah. Further diagnostics will be needed. This is just the initial video. I wanted to give you a look on just how to do the initial open up of these. Once you get to the point of taking that shield off, it is very much time to be ESD paranoid and go from, yeah, okay, I'm not getting any shocks, good to go, for like low cost, low precision gear, to it is now time to be very paranoid and religiously observe ESD precautions. You notice how I made no physical contact with anything inside there and maintained skin contact with my mat at all times. Because there's a lot that can go wrong if you introduce like any little bit of voltage to a component that's not supposed to get it. I'm going to leave it here. I've gone as far as I want to for this initial video. I wanted to get a look inside to see if I found any obvious problems. It's not as bad as I thought because we don't have the catastrophic capacitor failure, but we do obviously have a dead component. So I'm going to send that off to the seller I bought it from as the last bit of documentation to show, no, it's definitely not shipping damage. This was dead before it shipped out, because that did not happen from shipping. That's component level and board level failure. All right. See you, YouTube.